So last day, we did the first page of the day 4 notes, and we did the first page of these day 4 assignments. So today we're going to finish off the day 4 notes and finish off the assignment. All right. Now, what we started talking about last day was how to convert numbers. Fractions, if it's over 1, it can be written in 2 different ways. You can have a mixed fraction, where you have a whole number and the partial. Or you can write this, day 4, or you can write this as an improper fraction. Right? So, the procedure to go from here to here was the denominator stays the same because the number of pieces the circle is cut in doesn't change. So, stays a 4. To figure out the numerator, you multiply the 4 with the number outside. So 4 times 2 is 8. What? Add the top number, gave us 11. Right? So now, this is day 4, first part of the numbers. So, you're going to be given a lot of mixed numbers. When we're multiplying, when we're dividing, when we're adding, when we're subtracting. Your first step in any of those questions is going to be to convert that mixed number to an improper number. Then do the multiplying rules or the dividing rules or the adding, subtracting, whatever the question asks you to do. So your first step is to do what you did last day, is to convert. So let's go to the back side of this page. So we talked about mixed and improper fractions last day. Today we're going to do, hey, how do you multiply with these things? And your first step is to convert the numbers, right? So if I have this question right here, right, I want to convert the numbers. The 4 is going to stay the same. The 3 is going to stay the same. These two numbers are going to be multiplied. We need to figure out what the numerators are. What's the numerator here? What's the numerator here? Right, just like you did in your assignment. Right? So, to convert this to improper fraction, remember we multiply, then add. So, reminder, 4 times 2 is 8, plus 3, 11. So, this mixed fraction as an improper fraction looks 11 over 4. Now, the next one converted over, what would that one be? Sorry? 5. 5 over 3, right? 3 times 1 is 3, plus 2 gives us 5 over 3. Now let's do the same thing over here. Before we continue on, 5 times 7, we need to figure out what the top numbers are going to be here. Let's do both of these. All right, this question here. We're going to do 2 questions at once. All right, so if I want to, for the numerator here, you multiply, then add. 3 times 5 plus 2, gauge? 17. Yeah, 3 times 5 is 15. 15 plus 2 gives us 17. All right? Next one. 4 times 7 is what number? 28. 28 plus the 2? 30. Okay. So now, we have 2 questions changed over to exactly what day 3 notes look like. All right? Now we have 2 fractions being multiplied. What do? Is we compare tops and bottoms in all the directions to see if it can be made smaller. So, on this one, with 11, can it be made smaller with a 4? No. No. 11 and 3, can that be made smaller? No. No. 5 and 3, can that be made smaller? No. 5 and 4? No. No. So, no direction can this be pre-shrunk. Right? So, you just
55 over 12.
55 over 12. Multiply the tops together. Jagad, move your desk over, bud. 55 over 12. 4 times 3. That's it. Okay. All right. Next one. Okay. 17 and 5. Can that be made smaller?
No.
17 and 7?
No.
No. How about 30 and 7?
No.
30 and 5?
Yep.
Yes.
I think so.
What number can divide both? 5. So we cross out as a pair. Top, bottom pair, divide them as 5. So 5 divided by 5 is 1. 30 divided by 5 is 6. Okay? And we've done all of our simplifying in all the directions. So we multiply the bottoms together. 1 times 7. Right? 1 times 7 is 7. And 17 times 6, that's a little bit bigger. What number is that? 102. You can use your calculator for that. But there you go. That is our final answer. Now, last day I said, hey, if you're not good at simplifying beforehand, you can multiply just the tops together and multiply the bottoms together. And if you did that, you'd have 17. Now we've got my calculator on. 17 times 30 on the top, we would have 510. And 5 times 7, it would be 35. If you did this, you'd get half the marks. Remember? Though I do really, really encourage you guys to do this, because this is what you're going to need to do more of in grade 9 and grade 10. So take the time in grade 8 as we go really slowly to learn that method. Right? So, full marks here, half marks there. All right. I don't know if we're going to need to do all of these. Let's do... let's do a couple more. Let's do B here. All right? Let's convert the fraction. The number of pieces it's out of doesn't change. So the first numerator, right? Jay, not Jay, Jaden. Write this stuff down, man. Open it up. Multiply, then add. What number do you get?
26.
Not 26.
7.
7. Thank you. Adrian, can you do the next one? 5 times 5. Add the 2.
25 and
27.
They're like all blank.
Page 8. All right. Okay. So now, compare top numbers to bottom numbers. Can it be made smaller in any direction? Gauge.
3 and 27.
Yes. It can be both divided by the number 3. So cross off as a pair. 3 divided by 3 is 1. And 27 divided by 3 is 9. Oop. 9. Okay. That's as small as we can get it. So we multiply the tops together. 7 times 9. Yes, Jaden?
63.
63, thank you. And in the denominator, 1 times 5, 5. Answer, 63 over 5. Okay, let's do one more. Then we'll do a word problem, then I'll leave the rest of the class to get your assignment done. Okay, let's do this one.
What the?
The first fraction is not a mixed number. That's fine. So that one stays the same. The second fraction needs to change over. Right? Same procedure. Multiply, then add. What should the numerator be? 17. Right? 8 times 2 is 16, plus the 1 gives us 17. Okay, now, compare tops and bottoms. Can they be made smaller in any direction?
Well, why is it
No.
Oh wait, no, because this.
Yeah, you can't do 2 bottoms, and you can't do 2 tops. It has to be top bottom. So I saw a lot of people shaking their head. No, nothing can be done in any direction.
Dhaliwal?
Yes.
Why is it 17?
8 times 2 is 16.
Yeah.
16 plus 1, 17. Right. So 1 times 17 is 17. 2 times 8, 16.
So why isn't the other side 5?
Hmm?
Why isn't the other side 3 then?
Where?
The 1 over 2. Why is it plus on that side?
Sorry?
Why is there a plus there?
Which question are you referring to?
On C.
On C. Okay.
Why is there a plus there?
2 times 8
Yeah.
Yeah, and add the top number.
Why though?
That's how you convert it. Alright? You weren't here last day. You didn't come in for help, man.
It said, oh, no,
Yeah.
I wasn't here. I
Yeah.
was at the doctor's office.
Yeah, so this is the procedure. You gotta
I
know.
thought you said there were
Right? I can help you out a little bit more when we do the assignment, Jaden. Alright? Okay, that's it. So now let's just do one word problem, because I think you guys got this. Okay. So, next question. You're in baking class. You have a recipe that says, hey, you need 3 1/3 cup of flour. But instead of just making one batch, you want to make more. So suppose it's cookies or pancakes. You want to make 2.5 batches.
2.5
Batches. How much flour would you need then? The
Double.
recipe says for one batch, you need 3 1/3. But if you want to make 2.5 batches, how much flour do you need?
6 2/3.
Right? To do this. So now, are we going to need more flour or less flour?
More flour.
More flour, right? If we were just making double the batch, we'd multiply it by 2. If we're making triple the batch, we'd multiply by 3, right? If we're making 2.5 as times, we would multiply by 2.5. So this is how much flour we need, right? And we multiply by how much bigger we want to go, right? So we're going to multiply by 2.5, right? So now, turn around, man. Yeah. Swing your legs all the way in, man. All right, so the denominators stay the same. 15 over 3. No.
13 over 4.
Shh. Multiply, then add. 10. 3 times 3 is 9. 9 plus 1, 10. Next one, multiply, then add.
5.
5. Okay. Now, Gage, how can you make it smaller?
2, Jim.
2 and 10. Top and bottom like this. Cross them off as a pair. Both numbers can be divided by 2. So that's a 5, and that's a 1. 10 divided by 2 is 5. 2 divided by 2 is 1. 5 times 5 is 25. 3 times 1 is 3. 25 1/3 cups of flour. Now, in my class, I'm going to say, hey, 99.9% of the time, you can leave your answer as an improper fraction. Right? Just mathematically, all numbers are the same. Right? So leave your answer like that. Unless I ask you to switch to a mixed number, or just make sense. So when we are baking, we don't say 25 1/3 cups. We say 1.5, 2.5, 3.5, whatever it might be. So in this case, it makes sense to turn this into a mixed fraction. If I want to change this to a mixed fraction, see what you remember from last day, because we haven't talked about it. Remember, the denominator stays the same. We need to figure out what the whole number is, and we need to figure out what the number on top is. How did we do that? Remember?
1/3.
Thank you, Bryce. That was Bryce? Yeah. So where did the 8 come from?
The 3.
3 times 8 is 24.
Yeah. So you go 3 fits into 25 8 times. Right? That's where that is that's 24. We need one more to get to 25. So we need 8 1/3 cup of flour. Right? Okay. So we're going to stop there.